There we go. So what is Helm? Well, Helm is essentially a package manager like Homebrew or NPM or whatever, except it's for Kubernetes. So what does that mean? Well, it basically means that if you have a multi-service, microservice application that you've built on top of Kubernetes, you can wrap all of that into a single package and then use it. That's called a chart. So we're going to go into kind of the anatomy of that and how it works and the different components. But you over here on the right-hand side, you have kind of an example of an application with a bunch of different Go services, different databases, Mongo and MySQL. We've got a Node.js front end here. This has some Java backend, some .NET Core stuff is going on. So this is kind of what a typical 12-factor app looks like. Is you basically have all these different kind of components, and when you use Helm, you can basically define your service and the dependencies that it works with. So for instance, for that Node.js front end to work, you might need all of those components to spin up and run and be available. So if you're going to do integration testing and things like that. So why do you do that? Well, you get better application portability, and you basically get some help with rollbacks. You can make it easier to onboard new engineers on your team because they can come in and basically use what's been defined as the application. So we did some work with a customer the other day who has over 1,000 different services inside their company, and they don't really have a way of managing the dependencies. And so this is why we were talking about using Helm, because it would allow them to basically define out the dependencies of their application and then have that quick portability. Now, I said here that kube control apply is kind of dumb. I mean, it's not dumb, but it is a very simple kind of way of rolling out an application, and it has limitations in that it's not necessarily aware of the other things around it. So, for instance, I have an application that requires Mongo to be running, and so with Helm, I can basically say, I want this and then that. This is the order of operations for a rollout, which kube control is just applying an individual configuration, and you might have lots of configurations to apply. So how would we deploy this whole crazy microservice architecture? Well, Helm is going to make it easy for me to do that. So this is what a Helm chart would essentially look like, right? Is basically you define all of these applications inside of a Helm chart. And then use it. So words to know, and then we're going to get into kind of the components of Helm. A chart is a packaged Kubernetes resource. So that could be, you could have a chart for Nginx, you could have a chart for SQL, or you could have what we would call a chart of charts, which is for basically an application that has several charts in it. So it could be several, could be Nginx and SQL and Node and Go, and all of those things are kind of rolled up into a chart. The other thing to know about is a chart repository. So think of this as Docker Hub, but for charts, it's basically a registry where people can consume these charts. And we'll talk about the anatomy of a chart and what's actually inside of that in a second. And then the next thing to know about is a release. And a release is a chart that has been deployed, and every time you deploy a chart, it is a new release. It could be the same chart, nothing changed, but you redeployed it, that becomes a new release. And Helm is going to track all of your releases so that we can do things like rollbacks and comparisons and things like that. So Helm components that you should be aware of, there are really two sides to Helm. One is the client, which is what we use in the command line, and the other is Tiller. Now, Tiller actually lives inside of your cluster, which I'll show you. I'll show you an example. Let me split this out. What I should have done is, oops. Come here. There we go. What I should have done before this was separate out these two kind of components. Oh, it doesn't want to show it to me on a The rest of this video is just on effective window management in OS 10. Okay, there we go. Let's just move this out of the way. All right, and then we can come back to this in a second. Sorry, let me clean house a little bit. All right, so for Tiller, I just wanted to show you basically have a service running for Tiller. Where is it? In my kube system. There it is. So here's Tiller, and it's running inside of my Kubernetes cluster. Let me zoom in on that so you can see it a little bit easier. See how much we mess up the UI. So Tiller basically is going to sit inside of your cluster. When you initialize Helm, it will install in your cluster. Now, what does Tiller do when you need it? Well, the client is really a templating engine, and Tiller is really basically a release management. It keeps track of history, and it can do, because it lives inside the cluster, it can do kind of deeper inspection of health checks and things like that. So Tiller actually has a lot of values to it. I have a link that I wanted to share. I'll probably put it in the description of this video or something that talks a little about Tiller and all the things it does. But let me give you a sense of the Helm components here by jumping into terminal really quick. So I've got here an application. There's too much stuff on my screen. Nobody's going to be able to follow this. Let's clear this up. Let's zoom in on that. All right, let's clear it out. Okay, so I've got my Helm command installed locally here, so I can install packages or whatever I needed to do. Now, what Helm actually does when it creates a template is it creates a package. When you create a chart, you basically create a package of your configuration that you want applied. So let's actually step forward a little bit, and then we're going to come back to that. So those are the two main components, and the charts that we use to define our application are basically there are two components to that. One is the template, and one is the values. And so here you can see on the left-hand side, I have a template file, and it has values, and I can define default values if I wanted. And then you have a values file that basically says, for this repository I want to use Containers 101 demo chat. That's how I want to do it. And the value of that is you might have different values files for different environments. So for instance, it's fairly common in my experience to see people that have a values file that's for their staging environment and a values file that's for their production environment. And basically these values are partial, they do partial replacement. So if you have a template with default values set on it, and then you have a values file that only defines two of those values, it'll basically use the defaults, and then it will just insert the two new that you have defined. The other thing that we would use values for is we can actually manipulate those values inside of something like a CI/CD pipeline, which I'll show you in a second. But to give you an idea of how this functions, going back to this idea of here's your client and here's Tiller and what they're doing, I'll jump over to my command line again, and I'm going to issue, what I'm going to do is I'm going to use Helm to create a template here based on the chart that I have created inside of my repository. So I'm going to tell it Helm template and then the name of the chart here that I have. Now you'll see what this spits out is basically a collection of YAML files that define my deployments. They'll define my services. And what this is basically a template rendering engine that can create these YAML files for me. So in essence, what Tiller does, or the process here, is basically that Helm the client renders these templates, packages them, and then if you do like a Helm install, it'll basically send the package to Tiller, and Tiller will read the package and it'll say, okay, I'm going to go and apply all these things, and I'm going to keep track of all the things that you've installed over time. and I'm going to have a deeper kind of integration into your clusters, so I can do more health checks and make sure that things are working properly. So Tiller is kind of managing that outside component. Now there are some people who are really like Helm for the templating engine, and they don't like Tiller as much. I don't have really a problem with Tiller. I think as long as you kind of lock it down and you're security conscious, I think it's just fine. But if you aren't crazy about it, you can use Helm to do the templating portion only, and then you can basically manually apply those Kubernetes configurations, which is basically just a series of kube control, apply, file, and then all these files that we would create using the templating engine. But there are a lot of benefits to using Tiller, which I won't necessarily go all the way into. But that hopefully gives you some understanding of what's happening when we create a chart. Some introduction to, you've got these values files, you've got these template files, and then some sense of what the different jobs of these different components are. So with that being said, let's jump back into this presentation, and then what we're going to do is we're going to execute a little bit of a demo here. And here's what we're going to do. We're going to use GitHub branching, and we're going to use Codefresh for our CI/CD pipeline, and we're going to use that to build Helm packages and containers. We're going to push those images into Artifactory, which X-Ray can then scan and look for security vulnerabilities and things like that. And then we're going to deploy them into a Kubernetes cluster. Oops. And after that, we'll actually save this Helm chart into Artifactory so other people can consume it. Now, we talked about some of the use cases of Helm. There are a lot of really interesting use cases. Let me give you an example. So one of the things I talked about was application portability. Well, what if I wanted to take a change to a service or a set of services, and I wanted to do a full integration test? Well, I don't have to have like a staging server somewhere. Basically, I can dynamically spin up maybe a new namespace and install this Helm chart, run all of my end-to-end testing. I could even have manual testing happening, and then I can destroy the environment, and I can have confidence that it's going to be recreated in the exact same way that I just tested it. Another use case would be that I could save a chart, test a chart, save it, and then deploy it into a registry like Artifactory, where then my users can self-serve it to basically install the chart themselves and validate whatever it is that I've created or shared. So you could use that for product feedback. You could also use it for maybe making demos of your software for the sales team, where they can self-serve on-demand environments of your full application, essentially using this package. That's something that Codefresh actually kind of helps with because of, well, you'll see why, because this is what we're going to try to accomplish. So I've gone ahead and, yes, it's demo time. I've gone ahead and set up a pipeline to do this stuff. So let's go look at it. Okay. All right, so I've this is a cool little demo account that I created. I've got a couple of different demo accounts that you can potentially become a part of if you're interested. But this one is one that both Microsoft Azure and Google Cloud provided Kubernetes clusters for. So it's nice to see that cross-platform love happening. And then I've set up a couple of examples here for things that people can do. So let me give you a tour of our pipeline, and we'll execute some commands against it. Actually, I'm sorry. Before we go into the pipeline, let's look at Kubernetes and see what's running. So we've got here our two clusters. There's our Azure one. Here's our Google Cloud GKE one. You can see I've got my chart deployed into both of these right now. And I can inspect these. I can see what service is running. I can see the image that's running. And I can open the application. and here it is. So this is let's chat 99.2. We're going to change. Let's actually do that now, and we'll go on the tour of the pipeline. Let's make a, there we go. Let's make a change to this. And we'll go down and we'll change this to 99.3. Maybe we should make it more dramatic because people won't remember that we were on 99.2 and we went to 99.3. So let's say Feature Friday. We'll add that to the page. All right. And let's go. Man, my window management is not on point today. Let's go over to where this is going to be building. So I'm going to open up the pipeline and we'll look at the builds. So you can see I was testing it a few minutes before, about 44 minutes ago I was doing some tests. All right, so let's go ahead and commit this. We'll say Feature Friday shout out. And we'll push this, which will cause all the stuff we just talked about to trigger. And while it's building, we'll go through and look at everything that's actually happening. So this is going to kick off the build, and basically it'll kind of provision containers on demand to go and run this thing. So let's look at what it's actually going to do. The pipeline I created is this one. Now, this pipeline basically has a couple of steps. First, it's going to build the image. And one of the things that you'll see that I'm doing, and this is something I would suggest as a best practice, is I'm tagging this image with a combination of the branch and the revision, which is the short version of the commit SHA, which you can see like if you were looking at an image, for instance, this image, this is the commit SHA. So you can see that this image has been tagged with the commit SHA on it. Now, the really nice thing about that is if you have your commit SHA being used in your image tag as well as in GitHub, you'll always be able to reference those things very quickly back and forth, even if you're not on this image page. If you are on this image page, then of course you can just click this link and it will take you over to the change that was made. And here we can see that the last change that I made previous in the revision I'm looking at was just to change this point number. So a very small change, right? Now, let's go back into that pipeline. Okay, so in here, so that's something I recommend as a best practice. Another reason for that is that your Helm chart keeps track of the values that basically go into Kubernetes configuration YAMLs. And if you use something like an image master, well, if you go to do a rollback on your Helm chart, it's basically going to say pull image master. It doesn't know that you previously had a different version of that image. It knows what image you're referencing. So using unique images, unique kind of tags, such as ones that include the commit SHA here, are a really great way of making sure that you have great versioning in your chart and your application. And so if you do issue a rollback, you'll get exactly what you expect. So that's the build step. Here now I have my unit test step, which is basically going to run this npm test. It's going to grab all my test scripts, and it's going to set some metadata on this image to say that the quality has passed and that the quality is true. I could add percentages here. I could add links to external tools. For today's demo, I kept it fairly simple. Then the next thing I'm going to do is, well, I actually don't need this step. This one just grabs the Codefresh CLI and it just outputs the current Codefresh version. I did that because I was doing some debugging earlier and wanted to have this in there. I don't actually need it. But if I wanted to work with the Codefresh API from inside of the pipeline, this is where I would do that. Next, I have this step to deploy my image up to Artifactory. Now, the image that I built is automatically saved inside of the Codefresh built-in Docker registry that's just included for free. But here I actually want to push it to Artifactory because I want to get X-Ray involved. And using multiple registries in your CI/CD workflow is I would say, best practice because Well, you can actually tell you can tell how deep a team is into containerization based on how they treat their images, and it's what I'll see, and this is kind of a sign of an organization that's immature, is they'll use a single registry and they'll only push images to it that are tested. Well, if you make an image and it's broken, it fails tests, and then you don't push it anywhere, how is an engineer supposed to work with that image? They can't. They have to like go and recreate it themselves, at which point it might not actually be the same image. So what we do here is basically you have a registry that's for your development workflows, and it can have stuff that's good, or it can have stuff that's broken. And it's good because we can go do all our debugging. We can comment on images. We can go back and forth on it. And then I have over here Artifactory, which is like only the blessed images that have passed all the tests and I know are ready for production can go in. And I can like set a policy inside of Artifactory and say, unless this image has even passed these additional criteria, I'm not even going to allow it to be pulled in certain situations. So there's some security implications to that. But between Artifactory and the Codefresh registry, both of them use the same Open Graphis, I don't even know how to say it, Open Graphis standard, which basically is the way that we define annotations for images. So we can carry metadata on an image. Anyway, so this is going to push that Docker image, and you can see it's going to set that tag to be the branch name plus the commit SHA, and this is the registry it's going to push into. Now, the deploy step here, and what I decided to do on this demo is to deploy the chart before I saved the package. I kind of did that just because I thought it made sense to make sure that the chart deployed correctly before I added the package. But I'm basically, in some ways, I'm going back on what I said about using multiple Docker registries by doing it that way. I think I could. I would say that you can save your packages just depending on your setup. You might save them in multiple places, or you might save them multiple times with different kind of revisions on them. Anyway, okay, so this deploy step with Helm is going to grab the Codefresh Helm plugin. This is an image that we created that has the Helm tooling installed, and it has basically some scripting that will kind of let me just pass in my variables, and then it's going to go and figure out is Tiller installed? If it's not, it will install it. Is Tiller out of date? If it's out of date, it will update it. Once all that stuff is set up, can I deploy my chart? I can. Let's do it. Basically, it has a lot of kind of nice tooling that you don't have to recreate yourself to do that. Now, I'm going to get rid of this just for the sake of confusion. What this deploy step will do is I'm basically going to pass in some environmental variables, and these environmental variables are going to define what is going to be deployed. In this case, I have to set a chart name, I set the release name, I set the Kubernetes context, which is the name of the cluster. Now, because I've added this cluster to Codefresh, I don't need to do anything else with managing my permissions for it's all been defined already, and I can just reference it and use it. I'm going to tell it which namespace I want it deployed into, and then I can tell it this is the image repository. Now, these custom steps here, I'm pointing at my screen like you can see it. These custom steps here, what they do, the way that this plugin works is if you use this custom underscore convention for an environmental variable, is it will go in and look at the values defined for here, in this case, image repository, and then it will replace those values with what I have specified. So earlier, way earlier in the beginning of this thing, I talked about how you could dynamically manipulate values in a template in a CI/CD pipeline. This is what I was talking about. So here I can set the specific repository I want to pull from for this case. In this case, I'm going to use the Artifactory one. I can tell it which image secret I want to use, and then of course I can tell it which image tags I want pushed and which commit I want to use. And then this will deploy it into Kubernetes, and I can then package this whole thing up. And once I've made my package, I can push that package into Artifactory. So let's look at the build that we just did. I'm not going to do that. We can see that it was successful. It took 4.5 minutes. I'm glad that we looked at the pipeline during that time instead of just sitting and staring at it. And it looks like everything happened correctly. So let's open our application and see if it indeed rolled out. There it is. Boom. Feature Friday. Yay. All right, cool. So I've got that stuff going. Now, this chart is actually going to be visible now inside of my Helm releases. So I can see, and let's filter this by the cluster that I'm working in. I can see that I have this release called Demo Chat, this chart called Demo Chat. I can see it was last modified 6 minutes ago. I can open it up. I can see what services it has deployed. And then I can go over and I can look at the history and I can see all the revisions. So I can see the last revision here and what was changed since the last time I pushed it. Now, if I wanted to issue a rollback, I could just say, rollback. Yes, rollback. And this will go and execute a rollback from the changes that I made to my chart. I can also go in and I can explore the chart and the values and things that are set here. I can see what's been defined. I can which post-processing values were used in the Helm installation, which include like the pull secret here in the repository, and I get the manifest. So all useful, kind of nice little things that make my life a lot easier. But I can also go in, because I've saved this as a Helm chart, I can actually see it as part of this Helm registry that I have here, that I can see this chart that I have saved recently. And I can actually install that again if I wanted to on a separate cluster. Boom. And that will go and install that on the cluster for me, make it available. So that gives you some idea of some of the capabilities here of Helm. Looking at these charts, you can see that I've also got Kubex apps connected. You can add your own Helm repositories. So here, this RT Helm prod is actually running inside of my Artifactory instance that JFrog was nice enough to provide for the purposes of this demo. So you can basically add your custom stuff in here. And to show you a more kind of complete example, I'm going to switch over to, let's go to this one. And if I go over to my cluster, let that load. You can see I've got tons of different releases on tons of different clusters, and I can basically work with all of them. I can collect all the revisions. I can compare what changed in the history of these different things. I've got Prometheus, so I can see which values were updated. Here they are. So this is pretty nice. I want to see one that's not just a values deleted. This one's deleted. I want an example where I can show a diff. This isn't a good example. We'll do a different one. Let's see. So this one. There we go. Okay, so here I can see a diff of what changed in my values file. So this gives you a pretty good idea of how Helm works and how you would use it in a CI/CD workflow. Hopefully that's all fairly straightforward. It makes a lot of sense, and you get a sense for the benefits of using Helm. So with that, I think we are done. So thank you again for joining us for this Feature Friday. Always appreciate it. Please go ahead and feel free to leave comments in the YouTube, and feel free to share this with your friends if this is helpful. And you'd like us to see us do more, feel free to hit us up on Twitter at Codefresh. I am at Today Was Awesome. But if you have specific requests or things you'd like to see or questions that you'd like answered, or if you would like us to come in and help show your team how you can use something like Helm and Kubernetes and Codefresh together to kind of speed up your CI/CD, speed up your engineering workflow, happy to do it. Codefresh is really a complete tool chain for working with containers. So it has the pipeline component that we looked at, it has image management, it has real integrations into Kubernetes, it has Helm support, it has on-demand environments. So really everything you need to do DevOps, everything you need to provide a kind of control plane to your engineers so that they can actually build and test their software and release it, speed up their delivery and do all that good stuff. That's what Codefresh is, and we do have kind of these small free tiers for kind of the hobbyists, and all the way up to huge enterprise deployments on-premise behind the firewall where people are using Codefresh in some of the largest companies in the world, which is a subject that I hope to share more on very soon once I get a couple of case studies put together. So look forward to that. Also check out our blog. We've got lots of tutorials there, Kubernetes tutorials, Docker tutorials, and I think today we're going to be coming out with a really deep blog post on canary testing in Kubernetes, canary rollouts. So very excited for that. So thanks again for joining us in this Feature Friday. Have a wonderful day. Have a good weekend. Don't stop Kuberneting ever. Bye.